Grand. So we'll share a screen. What experiments would you recommend focusing on? I won't tell you a word of a lie. I have no inkling in what experiments come up. Like the most popular are your botanical composition, your DM of grass, milk hygiene, cation exchange, and what was the other one that I said that was very popular? Cation exchange, botanical composition. Oh, your earthworm population, your wormery. The wormery one was actually scandalously popular when I was looking over the papers. And like the wormery one is so easy, or the earthworm population is so easy to link in with questions like optimum conditions for earthworms, advantages of earthworms, all those different things. So yeah, like I've no inkling on what experiments will come up. There'll be experiments come up that you haven't seen before. You'll have to identify independent, dependent, controlled variables. But as at the end of the day, if I knew I was coming up, I'd tell you. I wouldn't keep the secret. Right, so let's crack on. Okay, hour and a half. We'll try and get through. I say it won't even take an hour and a half. I think of it fairly well broken down. I say an hour 15, 20 will get us through this. Okay. Again, try and keep the chat to ag science, and again, not our U values or anything else. And if there is any chance you send me a few experiments, Tim, I have them sent out. I've everyone emailed all the resources there. The email is acting up. I had to make a new email there this evening or this morning just to get the Zoom link out and make sure everyone got the Zoom link and the notes for today. But I have all the experiment notes sent out to you. If you haven't, just send me an email and I'll send it on to you when we're taking a break. But I will. You should have those notes. Sound okay? I presume the sound and everything else is okay, and hopefully we won't be doing too much lagging here. Right, okay, so this is the real bits and pieces. Okay, I couldn't not do soil. I was going to do like a mix mash of everything and all that sort of stuff, but I said, feck it, it's 4 chapters of the book. It's going to be probably 15 to 20% of the exam there tomorrow, so let's get cracking into it. So our soil profile. So what is a soil profile? Our soil profile is simply just a vertical section showing all the soil horizons known as a soil profile. So our soil horizons, A, B, C, and R, and up the top are O. Okay, so our organic matter, topsoil, subsoil, parent material, and bedrock. So 2 different types of processes that occur in the soil profile is known as elevation and elevation. So elevation and elevation, sorry. So I always think of elevation, think of an elevator. Okay, what does an elevator do? It moves up and it moves down. Okay, so elevation is the movement of soil particles or minerals from the upper to the lower layers of soil by precipitation or water. Okay, this is basically your leaching. Okay, the washing down of your minerals from to the B2 horizon, and then the elevation is where they all accumulate. Okay, so where all your minerals are going to accumulate, and that is going to be in the B2 horizon for where your iron pan is going to form in your podzols. Okay, so the accumulation of your soil particles and minerals from one horizon to another by leaching. Okay, so this is where all the minerals. What would the minerals be that accumulate? Anyone give me the 2 minerals that accumulate for your iron pan? We'll talk about it here now in a minute. Anyone know the 2 minerals that are going to accumulate? Obviously, one is going to be iron, and the other one is going to be not zinc, Connor. It's going to be aluminium. Now, there will be probably traces of zinc, but mainly iron and aluminium. So our soil profile, as mentioned already, is broken down into our layers called horizons. First one is going to be our O horizon, organic matter. This is going to be the surface. This is where the vegetation is going to be, whether it be your grassland, whether it be your tillage, whatever it is, or even kale or potatoes, what we were talking about last night. Our topsoil, so A is going to be our topsoil. This is going to be the most fertile. Okay, you often hear people looking for loads of topsoil for their garden. This is the most fertile part of the soil, contains all your minerals and organic matter through it. And leaching is going to occur here. So the zone of max leaching is your A2 horizon. So minerals are going to be leached from your A2 horizon down to your B2 horizon, where it's the zone of accumulation. Okay, so that is going to be in your subsoil for your B horizon. Going to be lighter in color. Lighter in color is basically telling us that it's less fertile. Okay, the darker your soil is, the more fertile it is. Okay, brown earth soils, uniform in color, very dark soil profile in comparison to your pod soil, where the A horizon is going to be bleached in color. C is going to be your parent material, rocky in nature, light in color. The characteristics of your rock is going to be the characteristics of your soil. If you have an acidic rock, you're going to have an acidic soil. Okay, all soils came from rock that just eroded over time. So you start down here with your rock got eroded up, and that forms your soil. Okay. So characteristics of your rock, characteristics of your soil. If you have an acidic rock like sandstone in your pod soil, you're going to have an acidic soil. If you have a basic rock like limestone in your brown earth soil, you're going to have a more alkaline pH. And then lastly is going to be your bedrock, which is going to be your solid rock down the bottom. Okay, so looking at our pod soil, I would say, can you label them O, A, B, C, R in the exam? Of course you can, Jake. Definitely can label them as that if you're asked to draw a general pods or a general soil profile, or even to label it, Jake. That could be a lovely question there. And my image from the posters, but we'll leave that story for another day. That we might do that in a podcast sometime. But you could be given a soil profile like that and just asked to maybe even give another name for the A horizon. You'll say topsoil, or another name for the C horizon. You'll say parent material. The pod soil is probably the one that's most likely to come up. Why? Because there's the most to talk about. So your pod soil is going to be found over an acidic parent material, which is going to be called sandstone. Poor. It's going to be a poor soil. It's going to be used for only forestry and rough grazing. So rough mountain grazing that we were talking about yesterday in our grassland. And the main thing with our pod soil, okay, it's going to be prone to leaching. Okay, key characteristic of your pod soil, it's going to be prone to leaching of minerals of our iron and aluminium. Where did we say? From the A2 horizon down to the B2. Okay, I want to burn that into your heads. The A2 horizon is where the leaching occurs, and they're all washed down, and we form our iron pan in our B2 horizon. Okay, this causes bleaching of the A horizon. So if the A horizon is bleached, that means it's less fertile. All the minerals are washed out of it, and they form an iron pan, which is impermeable, which can cause waterlogging. What does the word impermeable mean? Anyone going to tell me? So the iron pan can be removed using this machine called a subsoiler, often asked maybe in your farm machinery. Excellent. Can't pass through, Kira. Water can't pass through. So excellent. Impermeable, water can't pass through. Kira, nutrients can pass through. No, Kira, I'd probably say it's impermeable, that nothing really can pass through, but especially water. That's why waterlogging occurs. How do we increase the pH? Because of our acidic parent material, we raise it by spreading lime. We'll be looking at advantages of spreading lime there in a couple of minutes. Okay, so that is really the main summary of our podzoil soil. Okay, acidic parent material used for forestry, prone to leaching, minerals washed down, your iron and aluminium washed down from your A2 to your B2 horizon, forms an iron pan which is impermeable, which causes waterlogging. How do we remove an iron pan? We remove it using a subsoiler. And how do we raise the pH of any soil? We spread lime. Okay, onto our brown earth soils. Okay, so the best student I'd have in the class, I'd always say they were like a brown earth soil. Okay, BEST. Okay, that's what I'd say. Is C the sandstone? Yeah. So C down here is going to be your sandstone. C and R is going to be your sandstone. Yeah. Okay. So like you have your parent material, so a broken rock here, iPhone, but let's say down lower in your R horizon, it'll be solid rock of sandstone. Yeah. Great question. So brown earth soil is the best. Any characteristic that you can think of in soil, just say it about brown earth soil. Good structure, good texture, high levels of organic matter, very fertile, high levels of humus, dark in color, all those different things. So getting into the specifics of it, it's found over a limestone rock. So that is why it's going to have a higher pH, hopefully around that 6.5 level that we want. Suitable for crop production. And I would also say there, high stocking rate farming as well. Okay, so you could have a high stocking rate in regards to your beef or your dairy farms as well. Okay, so high stocking rate. Dark topsoil due to high levels of organic matter. It is high levels of organic matter. That means we're going to have high levels of humus. Where do we get the humus from? Humus is going to be broken down, or the organic matter is going to be broken down by our earthworms into our humus. Uniform brown color throughout our soil, which means there's little leaching. Okay, there's no bleach day horizon, so we have very fertile soils. Okay, brown earth soil will be an absolute dream to come up, because what do you say about it? Anything that you know about soil, just put the word good or improved or whatever. Anything good is going to be associated with a brown earth soil. Okay, the only thing that isn't going to occur in a brown earth soil is leaching. Okay, and obviously that isn't going to be good for our soil. Okay, everyone happy so far? Onto our gley soils. Okay, so our gley soils are going to be poorly drained soils found in waterlogged areas, and they have anaerobic conditions. Anyone tell me what the word anaerobic means? We were talking about it with our fermentation of our silage there yesterday. Is there anything else they can ask on the soils? No, not really. I won't tell you a word of lie. Yes, excellent. We're flying it. No oxygen, brilliant. I won't tell you a word of a lie. S, not really. Like your dream question there tomorrow is to draw a label diagram of a podzols soil. Like absolute dream. Put in all the labels, even put in a point or two how it's formed, why it's bleach day horizon. Not really. Okay, so the main thing here is going to be draw a label diagram and maybe give 2 or 3 points or 2 or 3 characteristics of it. Found over a limestone rock, so that could be you could say in common with our brown earth soils. But what is its main land use? It's confined to light grazing and forestry as well, our broadleaf trees, our deciduous trees. Gley is going to be formed in areas of high rainfall and have little leaching. Okay, anywhere where there's no bleach day horizon, there's going to be no leaching. Okay, our A horizon, limited structure due to the presence of grassland. Okay, what does grassland offer soil? How does grassland improve the soil? Anyone tell me? Anyone tell me how a grassland improves the soil? Excellent. Roots binds the soil together. Anyone tell me what type of roots? This is brilliant. Okay, super. John, brilliant. Talking about flocculation, the clustering of our soils together. We'll talk about that in a minute. Fibrous roots, brilliant. So when you have grassland, you can talk about improved soil structure with the fibrous roots binding the soil together. Excellent. Now, get the highlighter out for this one. Our B horizon, the main characteristic of our gley soil is they are mottled blue-grey in appearance due to oxidation and reduction of minerals. Okay, oxidation reduction is a type of chemical weathering. I haven't seen it asked in the papers yet, and I emphasize that word yet, but I swear to God, if I see a geography question in an ag science exam tomorrow, I will be ripping. 2 types of our gley soils is going to be a groundwater and a surface water gley. Groundwater gley are going to be found in depressions of lands called our valleys, and then our surface water are going to be formed in areas where they don't drain freely. Okay, so the water sort of sits on top of the soil and has low permeability. Again, permeability, impermeable means that water can't pass through it. Permeability means it can pass through it, but naturally, if it says low permeability, it's the same as saying impermeable. Okay, everyone happy with our gley soils? Okay, so what it has in common with our brown earth soil has a parent material of limestone. It's going to be waterlogged and anaerobic condition. What does anaerobic mean? If there's no oxygen, tell me more about the soil if we know that there's no oxygen present. What's the pH, Donica? To be honest, I'd be saying it to be a low 6. We'll say even 5.5 roughly. Okay, it's going to be a low. It's not going to be optimal because there's no oxygen. Okay, tell me something. If there's no oxygen in the soil, what else is there not? Okay, no earthworms, Mark. That's exactly where I'm going for. The earthworms can't carry out respiration. Okay, there's no humus in our soil. iPhone, I hope you're not the pink iPhone from last night, but no microbial activity. Excellent, super. There's going to be no mycorrhizal fungi that's going to be able to access nutrients deep within the soil. Brilliant. No earthworms, no mycorrhizal activity. Brilliant. Okay, so going to be a poor performance soil. You can talk about the earthworms, that there's going to be no worm cast. There's going to be no nitrogen, phosphorus, potassium in our soil, anything like that. Brilliant. Right, onto our peat soils. Okay, so anyone that's here from Leitrim, Our Longford will know plenty about these. So our peat soils are going to be our bog. Okay. Why is there no worms? There's going to be no worms because they have no air to carry out respiration. Okay. Think of yourself in a swimming pool. You go under the water, there's no air. If you're down under the water for too long, well, you're dushed. Okay, so that is why there's no earthworms. They can't carry out respiration. Okay, no organism can carry out respiration. Your bacteria, your fungi, nothing can carry out respiration. So our peat soils have an absence of all horizons except the O. Okay, so if you're drawing the soil horizon of a peat soil, you just are going to label the O horizon and say that all horizons are absent. Do you reckon peat soils come up as it has in past exam papers? Connor, I have a question about our peat soils at the end of this slide. How we preserve peat soil. Very, very topical at the moment. It came up in an exam paper last year. I say it could come again. That is why we'll cover it there at the end, because I really feel it's important. Peat soils, dark brown in colour. You would say that indicates fertility, but because that there's no air, it's anaerobic, poor drainage, it's going to be used for fuel in the form of peat or turf. Mainly used again for forestry and limited grazing capacity. Okay, why that point repeated again? Widely used for fuel in the form of turf. But yeah, Connor, I can't see being asked to draw a label diagram of a peat soil. I can't see that coming up. But what I can see coming up is how our peat soils are formed, or how we preserve them. Okay, we'll talk about that a small bit later. Umbotrophic and minerotrophic peats are two different types of peats as well. Umbotrophic, I had to look this up myself, but umbro is the Latin for rain. Okay, so where does umbotrophic get the water and nutrients from? They get it from precipitation. Okay, umbotrophic are going to have low levels of nutrients present. Okay, so that's why our pH is going to be less than 4. Okay, so very, very low nutrients available, and we get it, our water and nutrients, from the precipitation. Whereas our minerotrophic, okay, so miner, I think of, when I hear miner, I hear minerals. So we receive our water and nutrients from the ground, okay, from the soil, from the minerals in our soil, okay. Going to have a higher pH, okay, so more minerals are going to be available, so higher level of nutrients are going to be present, okay. Found in valleys where organic matter accumulates. Why does organic matter accumulate in valleys? Anyone tell me? What is that word about the factors of our soil formation? Anyone tell me? Last thing we're going to be doing. James Sweeney, good man yourself, fair play to you. You'll be working for Chagas there in 4 years' time. Topography, excellent. Okay, so think of your valley here. Okay, you have really thin soils. Let me get a different color pen. You have a really thin soil here on your mountain. Why? Because the water, rain is flowing down and it's all eroding down the mountain, and it all is going to accumulate here in the valleys. Excellent, okay? Topography refers to the slope of the land. So you have very thin soils on our mountains, okay? You're climbing up Croagh Patrick, you're climbing up the Sugarloaf, okay? It's all stone. Why? Because over hundreds of thousands of years, the mountains have been eroded down. That's just the rock left. And then when you look down in the valleys, you see all forestry, all grass, because that's where all the organic matter has accumulated, okay? That's my geography lesson over for today. Right, let's go. What is the name of the movement of soil particles or minerals from the upper to the lower levels of our soil by precipitation? Now, the movement, okay, the movement. Think of what goes up and down. John O'D. Illuvation. Lovely stuff, John. Good man. Soil horizon A is known as what? Topsoil. Good man, Bailey. Lovely. Our topsoil. Where is the zone of accumulation? Where is our iron pan formed? Donica is straight in with the B2, but Donica is going for the H1 tomorrow. What minerals are found in the iron pan? What are the 2 minerals found in our iron pan? 2 minerals found in our iron pan. How do we remove it? Mary is in with our iron and aluminium. And how do we remove it? Anyone tell us how we remove it? Remember that machine it's nearly like I don't know, a blade or a knife being stuck into the soil, just cutting the whole way along, is our subsoiler. Excellent. That's going to improve our aeration and drainage in our soil. Why is the A horizon bleached in podzols? Emma and Sarah is in with leaching. Brilliant. And Siobhan is talking about podzolisation. We'll all be working for Siobhan there now. Wanna watch Siobhan? We all working for Siobhan there shortly. List 2 traits of brown earth soils. Good soil structure. Absolutely anything you can think of to do with soils, just say good. Good structure. Fertile. High levels of organic matter. High levels of humus. Good drainage. Lovely. What appearance indicates a gley soil? Okay. Lovely. So anaerobic would be definitely a characteristic, but the appearance, okay, maybe not. If you're a Mua, you won't be going for this color, but a blue, gray, mottled appearance. Mottled basically means sort of patchy or spotted. Blue, gray, mottled appearance, okay, and that is caused by oxidation and reduction, okay. Name 2 types of a gley soil. So 2 types of a gley soil. We have what's going to be on the ground is going to be our surface, and we have our groundwater. Okay, brilliant. And lastly, what type of peat receives its nutrients from the groundwater? Okay, the ombotrophic received it from the precipitation. Ombro means rain. So this one, what type of peat? It's going to be a minerotrophic. Wonderful, lovely stuff, lads. We're flying it. Okay, onto our chemical properties of soil here. So, anyone, any questions? Are we okay? Everyone's fairly okay so far. Right, our cation exchange. Okay, boys and girls, listen up to this. This is how you learn your definition for cation exchange. Think of some fella or girl that you fancy. You have to be able to attract her. You have to be able to retain her. And you have to be able to get rid of her, okay? Are we not meant to be doing beef now? No, Donica, beef for an hour and then dairy for an hour after this. This is probably going to take an hour and a half, okay? So, cation exchange, the ability of a soil to attract, retain, and release cations. I don't understand why we don't like cation exchange. I think it's because people think it's to do with chemistry or whatever, but what are cations? Cations are very simply just positively charged ions, okay? H plus, potassium plus, calcium plus. Calcium ions, hydrogen ions, potassium ions. Okay, so how does our cation exchange take place? So positively charged cations are attracted to the negatively charged humus. Okay, so you see from this diagram here. So look what we have. Naturally, it's like, what's an ion? Okay, it's just a charged atom. So a cation is just a positively charged ion, and an anion is a negatively charged ion. For anyone doing chemistry Tuesday. But very simply, like your magnets, okay, plus is attracted to the minus, okay? So your soil particles are going to be negatively charged on the clay particles. This is going to be very important that we know this for our clay soils. The smaller the particle, the greater the cation exchange. The smaller the particle, the greater the cation exchange, the greater the surface area, okay? So our positively charged cations are attracted to the negatively charged humus particles, okay? So soil colloids are the smallest particle and they have the highest rate of cation exchange, okay? How are cations released? They're released either through weathering or they're absorbed by our plant roots, okay? Cations with 2 positive charges, like our calcium, can remove 2 cations with a 1 positive charge. So what I'm going to show you here, zoom in on this picture, a calcium 2 plus comes in and it kicks out our potassium that is +1 and +1. +1 and +1 is +2. Okay, so if a +2 comes in, a +2 is going to go out in the form of 2 potassium ions. Okay, does that make sense? If you're able to draw that diagram, you are basically explaining what your cation exchange is, okay? Please do not underestimate the power of a good diagram, a nicely labeled diagram there tomorrow, okay? Please draw diagrams. There's a space at the back of your booklet, extra space. You just write down at the bottom, C page, whatever of your booklet, and draw your diagram in. The examiner is going to have to correct it, okay? Factors affecting our cation exchange, all to do with the smaller the particle, you don't get it, Okay, right. We'll ask a question. What is the question? So let me see. If you have the example of a magnesium 2+ coming in, okay, magnesium has 2 positives, okay, there's 2 positives which are magnesium. That means that the example of a hydrogen that has a +1 and another hydrogen that has a +1 is going to be kicked out, okay. Does that, I'm not being smart, like, does that make sense that we have two positives coming in? That means 2 positives has to go out, okay? All about balance. We can't have 2 positives coming in and 1 positive going out, okay? If 2 positives are coming into the soil particle, 2 positive has to leave in the form of 2 + 1s or 1 + 2, okay? So hopefully that makes sense. Right. I appreciate people stopping me. If it doesn't make sense, please ask a question. I'll do my best to explain it again. Factors affecting our cation exchange is always going to do with the smaller the particle, the greater the cation exchange. So with our humus has the greatest cation exchange capacity. Why? Because it is the smallest soil particle, okay? So it can only hold 2 positives at a time. Zara, yes and no, like this is just for the sake of the diagram here. Like obviously it's going to be able to hold a lot of nutrients, but this just for the sake of the diagram here, just to show that if 2 goes in, 2 has to leave, okay. Right, our clay content as well, smaller soil particle has a higher cation exchange, okay. Clay content are small particles. Our soil texture, okay, the finer our soil texture, again, the smaller the particles, the finer the texture, the greater our cation exchange is going to be. And then with our pH, less cations are going to be available at low pHs. Where is the most cations going to be available at? pH is raised by spreading lime, okay? Hopefully we'll all know that at the end of this. Liming increases the number of negative charges in our soil. What is the pH on which the most nutrients are going to be available? Do sandy soils have a higher CEC then? No, amen. Sandy soils have a very low CEC. 1 to 5 for your sandy soil. Your clay soil is going to give or take about 30, or even greater than 30, up to 50. What is the unit? It's like MEQ, I think, per mil or something like that. 6.5 is the pH that we want to have. Yeah. But Eamon, great question. Your sandy soils, Eamon, are brilliant for drainage, aeration, all those different things, easily tilled. But because they're the largest particle, they have the smallest surface area for minerals to attract onto. So like imagine this is our sand particle, and then this is our clay particles, okay? We're only able to get, we'll say, 1 cation or 2 cations onto each particle for our sandy soil. Here for our clay, look at all the nutrients that we're able to get on because of the small particles and the greater surface area, okay? So hopefully we'll be looking at that aim in a small bit later as well. So that is our factors for our cation exchange. That is our cation exchange. Make sure you know the experiment that goes with it. Right, on to our Lyman. Okay, so hopefully Lyman is going to be an example of cation exchange that you can give in the exam. Okay, so if you're asked for the definition of cation exchange, the ability of a soil to attract, retain, and release cations, you can say e.g. liming, okay? And then if you really want, and if you have extra time, you can give this bit of a diagram as well. So what is happening with liming? Our basic ions are going into our soil. So these are going into our soil, and our acidic ions, our hydrogen and our aluminium, are coming out of our soil. Okay, so look, +2 and +2 is going into our soil. So that would give me +4 if my maths is right. And then H+ and aluminium, which is 3+, is going to be 4+ as well. So there's 4 charges going into our soil and 4 charges coming out of our soil. Okay, so always has to be balanced. Okay, so that is a way, hopefully you'll remember the charges. Your basic ions are going in. Why? Because the main purpose of carrying out liming is to raise our soil pH. If we have a soil pH of 5.7, we want to get it up closer to 6.5, maybe get it up to 5.2, 5.3. Okay, so what happens in liming? Our calcium and magnesium, which are basic ions, replace aluminium and hydrogen, which are acidic ions. And that process is known as cation exchange. Okay. Advantages of spreading lime. I would say that you need 3 to 4 of these here. Pick any of them. Okay. So anything again good with soil. This is where would you draw that diagram? I'd probably just draw that diagram, lad, at the back of the booklet. Okay, just refer in your question there, see back of booklet or see page 36 of the booklet, whatever, and then the examiner will go back and hopefully maybe correct that diagram and say, yes, this fella knows what he's talking about. So the advantages of our alignment: improves the nutrient availability. Okay, remember we were talking about last night, our nutrient availability is going to be very high at our 6.5 and then very low down here, 4.5, 8.5. Okay, not our nutrients available. If we have a soil pH down here, if we spread lime, we're getting closer to this 6.5 region that we want. Higher earthworm activity. That's going to improve our structure, improve our drainage, improve our aeration, neutralize acidic conditions, help animals' bone formation. Why would that? Could you say improve soil structure as well? Of course you could, Cormac. Of course you could. Improve soil structure as well. Like anywhere that you're saying it's improving or promoting flocculation, you can talk about soil structure. What was my question there? Helps animals' bone formation. Why? Would spreading lime be any point of improving sustainability or biodiversity? Sure, brilliant. Okay, like you're increasing the amount of earthworms and amount of insects that are going to be available in the soil because you know you have more nutrients available. Calcium, excellent. Okay, so there's going to be more calcium in the soil. Brilliant. So look at our calcium going in. Less parasites in our soil. Why would there be less parasites in our soil? Anyone tell me the reason for that? Why do you spread lime in your shed to disinfect it in the winter before your cattle go in? Anyone tell me? Calcium is, yeah, it sterilizes the shed. Excellent, Eamon, brilliant. The reason is more neutral pH, Ron, brilliant. The reason is that diseases or parasites love acidic conditions. So if you're spreading lime and you're reducing the acidic nature of your soil, there's less chances of stomach worms, liver fluke, any of those diseases being present in your soil. Okay, so that is why liming is such an effective method. And to answer that question above, it definitely could be done to improve sustainability and biodiversity in your soil. Brilliant. Right, on to our soil pH. Our soil pH, very, very common question, as simple as it is. It comes up in junior cert science. It's coming up in leaving cert ag science. What is it? It's a measure of the concentration of our hydrogen ions, okay? So pH extends from 0 to 14. I can't imagine you'd be asked that, but you could be given maybe this soil has a pH of 5.6. Is it acidic or alkaline? You're going to say acidic. As I said already, the characteristics of the rock is going to be the characteristics of our soil. If we have a sandstone or a granite soil, or a rock, I should say, we're going to have an acidic soil. If we have limestone in our soil as a parent material, we're going to be alkaline, okay, because of the calcium and magnesium present, okay? So sandstone, acidic, we have high levels of hydrogen and aluminium present. With our limestone, it's going to be alkaline, high levels of calcium and magnesium present. As we all know, our 6.5 is going to be that optimum range, okay? Anything outside that range, nutrients aren't going to be available in our soil. And the last part, I'm fairly sure of it, are chemical properties of soil, as someone mentioned already, was our flocculation. So what is flocculation? Flocculation is the clustering together of soil particles to create larger structures called floccules, peds, or aggregates, okay? Any lads there, you remember in your Champions League, you'd have your aggregate score, okay? You're putting the two scores together. So if it's 2-0 in the first leg and it's 3-1 in the leg, your aggregate score is going to be 5-1, okay? I think of a soil particle and a soil particle clustering together and we get a larger particle, okay? So that's just the way the brain works. Is it similar to cementation? Yes, Daniel. Flocculation would be an example of cementation. Yeah, so cementation is coming together of our soil particles. Flocculation would be an example of that. Brilliant, super point. So what is a floccule? A floccule is simply just a chain of colloidal particles. So what is colloidal? Colloidal is the smallest soil particle. Okay, whether it's colloidal clay, okay, the smallest clay particle, okay, high levels of cation exchange. And it's held together by water and the force of attraction between the water and the cations. Okay, so remember, our positive and negatives attract. Floccule formation is going to be excellent for improving our soil structure. Okay, now just even have a look at this. Not that it has come up before, but God forbid it would. And I think it's a lovely diagram just to even be able to draw, is your micropores and your macropores. Your micropores are the pores that are found within your actual soil particles. So these are your soil particles individually, 3 individual soil particles. These little holes in the particle is a micropore, and this space between the soil particles is known as a macropore. Okay, so the spaces between the particles is a macropore. The pores within the particle are a micropore. So you can see here at the end how all the particles are able to cluster together. What is an aggregate? An aggregate is basically where these single soil particles cluster together and form larger particles. Okay, so just even like what I have sort of drawn up here, and maybe I might do a better job at drawing it. If we had more particles all scattered, small particles scattered around the place, we could say that we have larger particles built up here. Okay, so a floccule, a ped, or an aggregate is all the same term. Okay, right. Built into it there are questions. So what is a chain of colloidal particles held together by water and the force of attraction between water and cations? So what is that? So it's like excellent, Ella. It is a floccule. Brilliant. Label A and B in our diagram, so we're just after going through it. So the space between the actual particle A is going to be known as a macropore, and then our B is going to be known as a micropore. Super. Define cation exchange. Okay, ability of a soil to. Okay, we want 3 words in this definition here. So let's just go to participants there and see if we can mute all. Allow participants to mute themselves. No. Right. So that's rid of that. Right. Brilliant. Okay, we have 3 words to put in. So attract, retain, and release. Okay, cation exchange. Attract, retain, and release cations from the soil. Cations in the soil. Brilliant. And then your cation exchange capacity is just the quantity of cations that are being attracted, retained, and released from the soil. Okay, so if that definition comes up tomorrow, cation exchange capacity is just the quantity of cations that are being attracted, retained, and released from the soil. Remember, your sand is a cation exchange of about 1 to 5, and your clay is give or take about 30 to 50. Okay, way bigger. Okay, smaller the particle, greater cation exchange. Right, 2 reasons why clay soil have a better cation exchange than sandy soils. Right, I'm after giving you one of them. A fine texture, that is a brilliant point. Okay, they have a finer texture, savage. Larger surface area, brilliant. Large surface area. And going to have smaller particles, super. So like that, there are lovely questions that to come up. 3 advantages of limon. More humus, brilliant. Okay, our clay soils are going to have more humus. But now, I really want to stress this to you. Please don't go into the exam tomorrow and write fine texture, because that's only going to get you half marks. You need to explain your points. There's loads of space in the exam. Please explain your points. Please give examples. Right, advantages of limon: it raises the soil pH, and then you can say the ideal soil pH is your 6.5. Wonderful. Promotes flocculation, and then who's that? Connor is going to even explain what flocculation is, that improve the soil structure because we have larger aggregates. Okay, over explain yourself. Okay, don't be there writing 2 or 3 words. Don't be lazy. This is your chance to show you know what you're talking about. Improves organic matter and higher nutrient availability. Why? Because we're closer to that 6.5 level. Lovely stuff. 2 factors that affect the rate of cation exchange. How many lines would you write? iPad, I said in a video there yesterday, for every 2 lines, I'd be given a point. So if there's a 6-line space, I would be saying you need 3 good points. We are going pH, humus, soil texture. And anyone going to give me the last one? Similar to humus, clay content. Soils with a fine texture have a something CEC rate, have a higher. Brilliant, Emma. Thank you. And Kieran, what humus has the highest amount of negative charges, giving it the highest CEC levels? Colloidal humus or colloidal clay is going to be the highest rate of cation exchange capacity. I'll just write that there. Cation exchange capacity. Wonderful. Soil pH is a measure of the concentration of the what? Ions in solution. So what ions? The hydrogen ions. Okay, the hydrogen ions are in solution. And state the optimum pH of soil for crop growth. If you don't know it at this stage, for all the times I've said it, 6.5. Okay, someone's going to get a tattoo there in Magaluf there next week or 2 weeks time there of 6.5. Okay, lovely stuff. That's chemical properties of soil. Right. Biological properties of soil. This is a heavy one. This is a heavy one. A lot of big information, a lot of new terms, and the dreaded cycles. The dreaded cycles. We'll just have to get on with them. Okay. So as the boys would say, lock in for this one anyways. Okay, so the rhizosphere. So what is the rhizosphere? I'm not going to tell you a word of a lie. It's a lovely diagram to draw. All you have to do is draw a root and draw an area around it and label it as the rhizosphere. Have these 3 labels. Your endorhizosphere naturally is going to be on the inside. Your ectorhizosphere is going to be outside that. And your rhizoplane is going to be this area here, okay? Between the rhizosphere and the rhizoplane is going to be the area between the rhizosphere and the actual bulk of the soil. Okay, so I got this diagram drawn. It's not just a hectic. If I was trying to draw a diagram for you, I'd be drawing it something like this, that this, we'll say this is the roots coming down. Okay, so we'd have, and then we'd have another area sort of outside here, and then we're going to have our sort of actual rhizosphere. Okay, so inside the actual blue, we'll say is our plant root. Again, not a hectic artist, but I would be saying that this is the endorhizosphere. Okay, so the endorhizosphere is going to be, okay, so that is the endorhizosphere. A halfway point, okay, like the black eyed peas, meet you halfway. This area here between the endorhizosphere and the rhizoplane is the ecto, okay, the outside area of the rhizosphere, the ectorhizosphere. And then lastly, this bulk area between the rhizosphere and the actual soil, rhizoplane. Maybe I just change color there. If I got a brown, let me see. There's a bit of a brown, and then all outside here is your actual soil, the bulk soil. Okay, endorhizosphere inside the root, ectorhizosphere the area between the endorhizosphere and the rhizoplane, and then the rhizoplane is your external surface of the roots touching the soil particles. What's the cortex of the root? Is basically the outside. Cortex or the epidermis or the endodermis is basically the skin, okay, or the outer layer of the root. Okay, so that is your rhizosphere. Please know the diagram, please know the labels. Like, I've given a quiz out on all the label diagrams. Please tell me that you know them, because such handy marks. Okay, there's loads of handy marks there tomorrow, but you just have to know the information. I suppose it's easier said than done. Advantages of mycorrhizal fungi. Okay, so mycorrhizal fungi. This is a soil here without your mycorrhizal fungi. not much roots. Here's the soil with your mycorrhizal fungi, loads of roots. Okay, so what are the advantages over mycorrhizal fungi? Okay, please learn this. I put a little heart behind that. Enhances your water holding capacity, reduces our drought in our plant. Helps bind the soil together, okay, in an aid of nearly flocculation, like fibrous roots. There's nearly more fibrous roots. The mycorrhizal fungi binds the soil together, improving the structure and reducing erosion. Those 2 points go hand in hand. When you're in the exam tomorrow, and if you're saying something improves the soil structure, say it reduces erosion, that's an absolute beautiful way of getting 2 points from the same point. Improves structure, you could say you could say improves flocculation, improves soil structure, and reduces erosion. There's 3 points from the 1 point. Sean, would you say mycorrhizal fungi would be symbiotic relationship in the soil? Sean, if you're saying it, I'm going agreeing with you. Absolutely. Okay, I was going coming back to her. Exactly like every teacher would say when they forget to do something. A symbiotic relationship, okay? We're 2 things. So what is it? It's the symbiotic relationship between the mycorrhizal fungi and the plant root, okay? So it's basically like an extension of the root, okay? The roots grow down, the mycorrhizal fungi attaches onto it. It enhances its water holding capacity. It can take up more water, therefore reducing drought. It binds the soil together, improves our soil structure. It has selective intake of nutrients. We'll go for a different color. So selective intake of nutrients, okay? Like a bouncer at the front of a disco, only going to let the good fellas in, keep the bad fellas out, keeping out the toxic minerals like lead, okay? So whoever was getting kicked out or got the red card there last night or yesterday morning, they're the heavy metals, they're the lead of our soil. And disease resistance is going to be increased, okay? So offers protection from disease. So disease resistance is going to be increased from nematodes such as who? Okay, such as our stomach worms. And we can also talk about our liver fluke. Okay, technically liver fluke isn't a nematode, that's actually a platyhelminthes, but you don't need to worry about that. Please know your advantages of your mycorrhizal fungi, okay? And that's just a bit of a diagram there that we were explaining about our nutrient uptake, okay? There are nutrients, 6.5, all the bars are really thick, okay? That means that the nutrients are going to be absorbed at that pH. Look at the up here at 9, okay, they're all thin, okay, maybe bar phosphorus there, but then again down here, like your podzols, maybe down here at 5.1 pH, all narrow, not going to be taking up any nutrients. Do we need to know the life cycle of liver fluke? Sean, I don't want to say you don't, but it isn't in the book. I'm sick of Sean. I'm really wore out of updating my notes every single year and the exam putting up something new. But I really would say you don't need to know it, Sean. But what I would say is that you need to know is how you prevent liver fluke. We'll be talking about liver fluke a small bit when we're doing beef. What percent of the exam will soil take up? Give or take 20%. Give or take 20%. Okay, like without being smart, it's 4 or 5 chapters of the book, and there's 30 chapters in the book. It's give or take 20%. Like there's going to be one experiment is going to be a soil experiment tomorrow, guaranteed. Your earthworms in your soil. Okay, so what conditions? This is a typical exam question. Give 3 factors or 3 soil conditions that Steve could do to improve his earthworm population in his soil. No, a farmer isn't going to go out picking earthworms from the ground and dump them on his land. No, that isn't going to happen. Why on earth can they ask questions not in the book? Conal Corbett, that is a question for Helen McEntee. Myself and yourself will go up to the doll, and I'll tell you something, she won't be going back to Navan in one piece. Okay, right, we'll keep it going. What are the conditions? Moist, well-drained soils, rich in organic matter and humus. pH of a range of 6 to 8, but ideally are 6.5. Warm soil conditions above 12 degrees and well aerated soils. They are the soil conditions that we need to have to increase our earthworm population, okay? And if you're a real farmer, you'd know. Bit of a challenge for us. I know it's a challenge for me, never mind challenge for ye. Benefits. So what are the benefits of having earthworms in our soil? Okay, so when we have our earthworms in our soil, what are the benefits? Okay, so convert our organic matter into humus. Okay, like our brown earth soils, improves our soil fertility. Would multi-species swarms increase our earthworm population? Absolutely. Okay, we'll put it in. Multi-species swarms, we have different types of roots binding our soil together, create more organic matter. Brilliant, super point. Improves the soil structure. Again, burrowing our soil, creating channels, improving the aeration. If we're improving aeration, that means that we're going to have more microorganisms in our soil, more earthworms in our soil, improving our organic matter, improving our humus. Earthworms are going to mix layers of our soil and bringing nutrients down to lower horizons. Okay, so taking the nutrients that's present in our topsoil, in our A horizon, and bringing them down to lower horizons in the soil, improving the overall fertility of our soil. And earthworms, they're earthworms casts or worm casts, which are basically going to be what earthworms excrete, are going to be very high in nitrogen, phosphorus, and potassium, and is almost going to act as an artificial fertilizer, going to break down any mineral matter and improve the overall levels of beneficial bacteria in the soil. Okay, so improving the rhizosphere, improving the habitat for mycorrhizal fungi, all those different things. Okay, I can't believe it, but like that wormery experiment is so popular. Like, I don't know why. I would say 25% of teachers do the experiment with the wormery, but it is a popular one to come up. And like all it is, lads, is you have different layers in the soil, you put your earthworms into it. Okay, the one that you put the earthworms into, it's going to go pure brown in color. Okay, it's going to be all mixed up together. The ones that doesn't have earthworms, naturally, it's not going to mix. Okay, sometimes that you put leaves on top of the soil there, and the earthworms are going to come up and bring the leaves down into the soil. That's another thing as well. But I can't, like, it is a popular question to come up. Absolutely lovely question. Improve the drainage, improve aeration, improve soil fertility, improve soil structure. How long do you leave them in the wormery for? Where do you get the earthworms? You get the earthworms from the ground, Steve. You go out and put water and fairy liquid solution together, pour it over a quadrat, and the earthworms come up to the surface. Why? Because the fairy liquid or the washing up liquid removes the air from that section of the soil, and the earthworms have to come up to the surface then. So that's where you get the earthworms from. And that's how you do your earthworm population calculation. Ella, how long do you leave them in the wormery for? They have to be in a dark room covered for give or take a week. Give or take a week, they'll have their job done. Right, organic matter. Okay, functions of our organic matter. What is organic matter? We're talking about it all evening. Organic matter consists of dead remains of plant and animals. Okay, so dead remains of any insects or anything like that, or any dead leaves. And the organic matter, when it's decomposed, is going to be known as humus. We have different functions of our organic matter. So we have biological functions, we have chemical functions, we have physical functions. So biological functions is going to be our nutrient reservoir. So our minerals are going to be available for our plant and animal uptake naturally. If we have, as we were saying earlier with our limen is adding calcium to our soil. And if there's calcium in our soil, that means our animals are going to have good, strong bones, and they're not going to get milk fever. Okay, if there's no calcium in our soil, the animal's going to have weak bones and are going to be prone to milk fever. Is organic matter only dead remains, or is it both living and dead too? I would say, Sean, that it's dead remains. I would say that it's dead remains of plant and animals material, because it's organic matter is basically going to be recycled from the surface into the soil by our earthworms. Carbon is sequestered. Okay, what does sequestered mean? So carbon is sequestered in humus for long-term storage. What else is organic matter going to do? It's going to improve our biodiversity. Okay, that's another lovely point there to say. To improve our soil condition, to increase the levels of organic matter, will improve the biodiversity in our soil. What does the word sequestered mean? Carbon sequestration. What if that term comes up tomorrow? Are you going to be scratching your head? Carbon sequestration is released, okay, is the removal of carbon dioxide from the atmosphere. So removal of CO2 from the ATM, the atmosphere. So micro and macroorganisms sustained in the soil provide organic matter with or provides them with nutrients and energy. Sorry. So micro and macroorganisms. So macroorganisms is going to be your earthworms. Microorganism is going to be the likes of your mycorrhizal fungi and beneficial bacteria. Okay. Chemical functions, as we talked about already, pH buffering, okay, keeping that soil pH at your 6.5, increasing your nutrient availability and your earthworm population. How many questions do we have to answer tomorrow, and out of how many? Donica, have a look at that video I put up on Instagram there. You have 16 short questions and you have to answer 10. And now, like, obviously question 3 is going to be answer A or B. Obviously, if you answer A and B, it still counts as one question. And then your long questions, you're going to have 2 questions with 4 parts, but you only have to do 3. You have to do A and B, and then C or D. Okay, that's going to happen in 2 questions. So I'd suggest doing those questions because you have loads of choice. And then the other 3 questions, they're going to be part A, B, and C, and you have to do all the parts. 10 short questions, 4 long questions. Yeah, short questions worth 100 marks. Long questions worth 200 marks. 10 by 10 for your short questions, 4 by 50 for your long questions. Will we 100% have to answer on soil life? Donica, yes. Cation exchange. I have yet to see a paper that you'll be able to avoid, Donica, to be honest. Cation exchange, our colloidal humus is going to increase our cation exchange in our soil. Our organic matter is going to release nutrients, our nitrogen and phosphorus in our soil by mineralization. We'll talk about that in a second when we come on to our carbon and nitrogen cycle. And then physical functions, reduce soil compaction. Okay, big chat about that there now later. Reduces soil erosion, water retention, and improves our soil structure by flocculation. Will you have time to think, or is it flat out writing the whole time? Emma, no, it's not English paper 2. Emma, I say you could go in and you could scratch yourself there for the first half an hour and you still have time to get it done. Emma, first 5 minutes, just breathe, relax, open the paper and just start writing down. Any teacher that tells you to do the long questions first is a dope. Do the short questions first, warm yourself up into the exam, get a half an hour into the exam, and then you're going to start thinking of ideas, okay? And then go to your long questions and start working your way through them. Just start jotting down what you know from each question, and then go back and be like, right, what questions do I know the most in, and start adding your detail in. You get the whole thing done, wouldn't you? Absolutely, Eamon. I would be doing every single question on the paper. Better off doing a good hour and out the gap. Donica, don't do that. Please don't do that. Right. How do we improve our organic matter? This is a very common question. How do we improve our levels of organic matter in our soil? Sowing a catch crop, okay? Like our kale, like our stubble turnip, our crop rotation. Someone give me a benefit of crop rotation. We have 3 benefits. 1 is improving our soil structure. What else is a benefit of our crop rotation? Would you need to do a few stretches beforehand? No. Reduces pests and diseases. Brilliant. Reduce diseases and pests, and higher what? Nutrient availability. Okay, different types of roots in our soil. Excellent. Okay, farmyard manure. Naturally, what is in our farmyard manure that's going to add organic matter? What is in the farmyard manure? Why do we not say slurry? Straw is present in our farmyard manure. Excellent. Min-till. What is min-till? We didn't cover reseeding, but what is min-till? Min-till is a reseeding technique that doesn't involve what? No ploughing. No ploughing. Okay, give me an example. I hear you. Direct drilling. Lovely. No ploughing involved. And return to pasture. Okay, why? Return to our grassland because we have those wonderful fibrous roots. Lovely. Brilliant. Right. Organic matter loss affecting our farm productivity. What is going to happen if we have organic matter loss, if we don't have organic matter in our soil? Basically, the opposite of all our benefits. Okay, so like look at our benefits here. Okay, anything good to do with our soil is topping stubble cleaning. No, Steve, stubble cleaning is letting the weeds grow back up and ploughing it again. Topping is mowing the grass to 5 to 8 centimeters, encourages tillering and controls weeds. Okay, and it's done post grazing. Okay, so just well, great question, Steve. Stubble cleaning is an example of indirect control. Benefits of your organic matter improved soil structure, water holding capacity, increased cation exchange capacity, improves your pH buffer, soil drainage, better root growth, presence of microorganisms in your rhizosphere, acts as a carbon sink. Okay, stored carbon sink is basically another way for saying stores carbon. Okay, that not releasing carbon into the atmosphere. That is a huge advantage of your peat soils. Okay, that is why we want to conserve our peat soils. Okay, and keep Greta Thunberg happy. As Trump said, she has anger issues. I would agree. Organic matter loss, the effect on your farm productivity. It decreases your nutrient stores, decreases your soil biodiversity, your earthworm population, more susceptible to drought, and a decrease in your soil drainage. Okay, how do we reduce this effect? This here is the same. So how do we reduce our organic matter loss? Is basically the same as this answer up here. How do we increase our organic matter in our soil? Would you recommend printing this out? I don't know, whichever you can learn best from. So if they ask how a farmer could improve their carbon footprint, could you say they could increase their organic matter in their soil? Yes, to take in carbon. Absolutely, Sean. Brilliant. Super. Absolutely. Right, let's go. What is the total mass of living material in a habitat? Okay, we didn't talk about it, but I just said throw the question in. See, do you know it? Anyone know? It's our biomass. Yes, Mark is on the ball. Mark is on our ball. It's the soil biomass. Two functions of soil microorganisms. So what's the function of our mycorrhizal fungi? What's the advantages of having microorganisms in our soil? Why do we want them? Why do we want them? Anyone tell me why we want them? Improve our soil structure. Excellent. Okay. What's the key one? Improve soil structure. What do microorganisms do? Recycle. Reduces erosion. Yes, like that. Reduces erosion, improves our soil structure. Yeah, all linked. It recycles nutrients or minerals. We'll say nutrients. Recycles nutrients into the soil, improving our OM levels and improving our humus levels. Label the rhizosphere A, B, and C. Okay, so we'll go for this being A, this being B, and this being C. Okay, so what is this one here? Okay, I'll try and zoom in at that diagram there. So this one here is actually touching the root. This one is the happy medium just outside, and this is the area between the rhizosphere and the bulk soil. Right, what is A? A is what? A is our endorhizosphere, Thomas. Brilliant. Okay, A is our endo. B is just outside here, is our ectorhizosphere. Lovely, Emma. And C is going to be our something plane, our rhizoplane. Lovely. Two advantages of our mycorrhizal fungi, as we've mentioned already. A beautiful relationship. The relationship you want. Symbiotic. What are the advantages of our mycorrhizal fungi? Disease resistant. Okay, super. Builds up disease resistance. Anything else? Selective intake of nutrients. Okay, allows good nutrients in and keeps the bad nutrients out. Selective intake of nutrients. Okay, so allow the nitrogen, phosphorus, potassium in, keep the lead out. Drought resistance. Lovely. Flying it. Mention 3 ways to increase our organic matter in our soil. Water holding capacity. Lovely. Right. Increase the amount of organic matter in our soil. Have earthworms. Crop rotation. Farmyard manure. We could say lime. Yeah, I like that one. Spreading lime. Min-till and return to pasture or to return to grassland. Excellent. If our organic matter is 4.3, what is the levels of our soil organic carbon? So just very quickly on our maths, our soil organic matter multiplied by what gives us our soil organic carbon? multiply by 0.58. Thank love of God that you know that. Okay, brilliant. 0.58. So John, be careful of that. And we are getting, so 4.3 multiplied by 0.58, and we're getting an answer of 2.49%. Wonderful. Excellent. 3 conditions needed for optimal earthworms. Okay, let's go. How do we increase well-drained soils? Well-drained soils, lovely. Suitable soil temperature, okay? So a temperature of about 12 degrees, I think it was. Well aerated. Super, okay, that they can carry out respiration. Organic matter present, brilliant. Okay, what are the benefits of our earthworms? What do they improve? They improve everything in our soil. Just start naming, even if you don't know, start naming soil characteristics. Soil structure. They improve the drainage. They improve the levels of our organic matter. They improve the levels of our soil fertility. They reduce erosion. Excellent. I'm loving that point. Reduce the erosion. Increase your yield. Okay. How do they increase the yield? Because their worm casts contain nitrogen, phosphorus, and potassium, reducing the cost that you'd have to spend on your fertilizers. We're flying it. Right. On to this girl. Oh, Lord bless us. Mix the soil layers. Okay. I'm just going to say it, and I know this is being recorded, but I guarantee you this will come up tomorrow. I guarantee it. Farmers aren't allowed to spread urea on their land anymore. Protected urea is the only form of urea that you can spread in your land anymore to reduce the emissions. Advantages of protected urea will come up, and if that comes up, I think it will be linked to the nitrogen cycle. Okay, as a long question. It can't be a short question. It has to be worth more than 10 marks. Would you be asked to draw it and explain it? I would say you'd be asked to do both. You'd be asked to draw it and explain it, I think. Really, really think the nitrogen cycle. I hope the carbon cycle doesn't come up tomorrow and you're all cursing me, but what are the advantages of protected urea? Cation, DM me urea on Instagram and you'll get a link to the website and you'll get a free note there. Hardly get both in the one exam, Eamon. No, I don't think so. This is an Evan Boland if she's coming up or not, but I really think it's going to come up. Right, let's get into it. Nitrogen fixation. Nitrogen fixation is what clover does. Okay, takes nitrogen gas from the atmosphere and converts it into nitrates. Right, lads and girls. A in nitrates. A in plant. Nitrates is the only form of nitrogen that can be taken up by plants, by grass, by crops, by whatever. A in nitrates, A in plant, okay? Nitrification is the process on which ammonium is converted to nitrites and then to nitrates, okay? You have to know that nitrates is going to come last because that is when the plant is going to absorb it, okay? After that, it's the plant absorbing the nitrates from the soil, okay? Ammonium to nitrites to nitrates. And then denitrification is where nitrates are lost from the soil and put back out into the atmosphere as atmospheric nitrogen. Would I have to do a diagram, Denise? Yes. Could you use what you know from biology for this? Yes. Is the nitrogen cycle the same as the one in biology? Yes. Step one, atmospheric nitrogen. So I call step one everything to do with clover. Okay, so I don't think you need to draw the massive. I break it up into three or four bits there, and I think it's far handier than drawing this massive yoke. So step one, what do we have here? Let's look at the diagram. I love looking at diagrams explaining. Right, our clover here. Our clover, the root nodules of our clover contains our rhizobium bacteria. And the rhizobium bacteria has a symbiotic relationship with our clover. And our clover is going to take atmospheric nitrogen and push nitrates into the soil by the process of nitrogen fixation. That is what our diagram there is telling us. That is what that diagram is saying. So let's go over to the text. Atmospheric nitrogen diffuses into the soil where it undergoes nitrogen fixation. So our rhizobium bacteria found in the nodules of our clover has a symbiotic relationship. And what is going to happen is that the atmospheric nitrogen is absorbed by the clover through the process of nitrogen fixation. Yes, N2 gas in the atmosphere. Yeah. Plant and clover naturally going to reduce our need for our fertilizers. Right. Okay. Then we're on to our clover. We have our nitrates in. Right. What is going to happen? Two things is going to happen. Our clover is going to be eaten by our cow who produces animal manure, or the clover is going to die and produce green manure. So two things is going to happen to clover. Eaten by the cow who produces animal manure, dies itself to produce green manure. Both of these are going to be broken down by the soil microbes, okay? Your mycorrhizal fungi, your rhizobium bacteria, all the soil microorganisms break down the plant manure and the animal manure and convert it into soil organic matter. Okay, that is that diagram explained, and that is exactly what I've written here. I call step 2 is just about our manures. Plants are eaten by the animal who produces animal manure, and they either die producing green manure. Microbes break down the manures, which adds organic matter to the soil. Okay, the organic matter is going to be converted into humus to improve our soil fertility. Now, this is the money shot. This is nitrification. This will send you to UCD. So this organic matter that was broken down undergoes a process called mineralization. Okay, organic matter is converted into ammonium by the process of mineralization. The ammonium undergoes a process, as we've talked about already, called nitrification. So remember, ammonium to nitrites to nitrates is the process of nitrification. But two different bacteria carry out this process. So we go from ammonium to nitrites by Nitrosomonas bacteria. Now, how do you remember it? Okay, again, I am on for absolutely anything. Lads, Adebayor was a footballer for Man City, and he scored a goal against Arsenal, who he used to play for. And I remember in history learning about a Roman cloak that they used to wear, and it was called a toga. And Adebayor was from Togo. And I was like, right, that's how I remember that. Absolute nonsense. Nothing to do with the Romans, nothing to do with history. God bless Adebayor. But here we go. I have O in ammonium, and I have O in Nitrosomonas. Okay, that is how we're remembering that. And then we go from our nitrites to our nitrates, and that is Nitrobacter. We have A in Nitrobacter, and we have A in nitrates. Okay, will I do that in a different color for you, just for in case? So A in Nitrobacter, A in nitrates. Okay, that is your nitrogen cycle. Okay, three things are going to happen in your nitrogen cycle, very similar to your carbon. Your nitrates are going to provide proteins for your soil microorganisms. That's known as immobilization. Your nitrates are going to be leached, or they're going to be diffused back into the atmosphere by denitrification. Could you sneak the diagram into your pencil case? Probably not. No. I like this. Yeah, I really hope this comes up. I really hope it does. On to the easier one, the carbon cycle. The carbon cycle, very simple. This is about our photosynthesis. So our photosynthesis, plants take in our CO2 from the atmosphere during photosynthesis and converts it into carbohydrates. Plant roots respire and naturally are going to produce carbon dioxide. So your plant is carrying out photosynthesis and respiration. Look at this diagram here. The plant is absorbing carbon dioxide through the process of photosynthesis into the plant, and then at night it's carrying out respiration through the roots, releasing carbon dioxide down into the soil. Okay, You do need to know these formulas. Yeah, I say the chemical one. If you're doing higher level, you'll be asked for the chemical one. Okay, C6H12O6 is the formula for glucose. That's the only one you need to know. What are the chances of the carbon cycle coming up? Okay, I'll tell you my logic. Okay, so in 2021, I'm fairly sure both of them, somewhat of a question came up on both of them. 2022, nil. 2023 was nitrogen. 2023 was carbon. 2024 was nothing. And then 2025, like, surely it has to be the nitrogen cycle. With the protected urea, with everything else, I really feel it is. I really feel it is. Carbon and nitrogen came up in 21, skipped a year. We got the carbon then, skipped a year. Surely to God, lads. Okay, that's my Keith Barry working out in it. Okay, that won't be going on Instagram. So I really hope it comes. I really hope it comes for you. So, but just taking all that away. Okay, let's see. Okay, and I'm sure some of you will come and tomorrow and call me every name under the sun, saying that, oh, you said that it would come up and I didn't learn it. Well, guess what? You were here for the last 10 hours, or you were with me for the last week, you were with your teacher for the last 2 years. So that's it. Right. How do you learn this? Okay, it's CO2 taken in from the atmosphere. You take water in from the soil. Sorry, lads. I want to hurry up there now because I have another chapter to cover in a couple of minutes. Right. CO2, H2O, oxygen. The only hard one to learn is the glucose, C6H12O6. Okay. We add in our pluses. We put in our line. We add in our plus here. We need light here. And we need chlorophyll from our leaf for our photosynthesis. And what do we put? A big 6, a big 6, and a big 6 in front of all the simple ones. Okay, yeah. So you need to put a 6 before the simple ones, the carbon dioxide, the water, and the oxygen. Okay, make sure it's balanced. Okay, be a lovely question. That'd be a lovely question to come up, and then know what would come after that would be like the adaptions of your leaf. Okay, your waxy cuticle, having your stomata, talk about your palisade layer, large surface area, thin for diffusion of gases, all those different things in your plant physiology. Beautiful question. Right. On to our manures. Plants are eaten by our animals, which respire to produce carbon dioxide. Okay, so carrying out respiration to produce carbon dioxide. Plants are going to produce green manure when they die. Exact same as our nitrogen cycle. So crop is going to be eaten by our cow, who carries out respiration, releasing carbon dioxide into the atmosphere. He's going to produce animal manure. The crop dies, produces green manure, and again going to be broken down by your soil microorganisms. Your soil microorganisms, what are they going to do with it? Well, they're going to also carry out respiration and produce carbon dioxide in the soil. Okay, so what is going to happen is that 3 results happen here. It's either going to be converted into carbonate ions in the soil, it's going to be lost through leaching that we see in our podzols, or it diffuses back into the atmosphere. Okay, we never did. Are you covering plant physiology, Sean? No, I'm sorry, Sean, I can't cover everything. Is the break at past, Jake? It probably won't be. It probably be a small bit after it, just at the pace we're going. Right, we'll answer a couple of questions. Right, what's the chemical formula? You never did plants, Connell. Honest to God, how are some of these teachers getting paid? Anyways, what's the chemical formula for glucose? Okay, C6. Come on, the number of Champions Leagues Liverpool have won. C6H12O6. Lovely, Ava. Brilliant. When plants die, what do they produce? Type it out. Every single person in this chat, type it out. C6H12O6. Do it. Type it out. You'll think of it tomorrow. C6H12O6. They produce green manure. Excellent. And while you're typing it out, I'll answer a few questions for you. Type it out. C6H12O6. Carbonate ions can be taken up by the plant roots, but they also can be lost through the process of leaching. Brilliant. Okay, we're all in this together. C6H12O6 is your glucose. Okay, when you're writing out your photosynthesis formula, it's the opposite. It's the opposite for respiration. It's glucose plus oxygen gives us energy, oxygen, and water. Okay, brilliant. How does carbon dioxide move into the atmosphere? What is the process? How does it move? Not by osmosis, not by active transport. This is where the biology women are going to come into it. Diffusion. So someone said denitrification. Jim, that is going to be in the nitrogen cycle. This is the carbon cycle. Good man. Right. What process is where nitrogen gas is converted into nitrates by our plant? It's going to be by our clover. It's going to be by our rhizobium bacteria, and they are going to have a symbiotic relationship. Come on. We are flying it here. We're flying it. Nitrogen fixation. I hope every one of you are writing about it tomorrow. I can't wait for you to write about it tomorrow. Nitrification is conversion of what? From nitrites to nitrates. Lads, A in nitrates. A in plant. Some of you are learning here tonight how to spell plant, but that is okay too, as long as you know that plants take up nitrates. Okay, so conversion of ammonium to nitrites to nitrates. What type of relationship do rhizobium bacteria and the root nodules of the clover have? If you don't know it at this stage, there's no refund. What bacteria converts our ammonium to nitrites? Okay, the first step. Okay, O in ammonium. What type of bacteria? Nitrosomonas. I can spell nitrosomonas, but I can't spell anthelmintic, whatever. Nitrates undergo what process where nitrates are converted back into nitrogen gas in the atmosphere? Jim, you should have the answer there for that one. You had it before anyone. Denitrification. Siobhan and Emma have it as well. Lovely. Right. Okay, right. Very quickly on to our physical properties of soil. Okay, I wanted to spend a bit of time at that, lads. I really hope, honest to God, from the bottom of my heart, like, it's in my interest to hope that it comes up as well. I really hope everyone here does well in the exam tomorrow, obviously, but I really hope that comes up for you. Michael is coming in here now. Michael must be at a different time zone like myself. He must be over in Spiddle there, where they're an hour behind, no electricity. Over on Inish Turk. Cash back for any H1s. No, you have to pay me double if you get a H1, Eamon. Double if you get a H1. I want you to put me in a private jet straight to Boyle. Private jet straight to Boyle. 200 H1s all around. The Farmers Journal will be looking for me then. Galway races, straight for the Galway races. 50 cent each way on the favourite and get 42 cent back because he won. I actually lost money because the horse won. Right. Refunds for anything lower than a H5, no. You have been in my care for the last week, and you've been in your teacher's care for the last 2 years, so absolutely not. Buy you a pint of H1. Billy, I hope you do, because your email wasn't working, so I hope something will be working there tomorrow anyways. Yeah, definitely. Come on, Billy. Thank God you got that email cleared out. God knows what sort of subscriptions you have coming in that is it all flooded. Refunds if you get an 08. No 08. No, I actually don't think you can get an 08. Connor, there's a break coming in 15 minutes. We'll keep it lit. Right. Difference between our sand and our clay. Okay, less of the shy talk. So sand particles are going to have large soil particles. That means we're going to have good drainage. Okay. I'll just make this a small bit smaller that you can see it all. Let me see there. Yeah. Good drainage, good aeration, easily tilled, warms up quickly, and going to be drought. Okay, think of the drought. Think of it when you're on the beach. The tide comes in, the water goes down in the sand straight away. Okay, fertility, little to no ion exchange. So basically the sand is all good. Well, I'll take that back about the drought. But all good things about sand, but little to no ion exchange. Remember, it's 1 to 5 in the cation exchange capacity. And then our clay is going to be small soil particles, poor drainage, poor aeration. Okay, Plasticity in regards to tillage capabilities. Okay, going to be a cold soil, prone to waterlogging, but then it has that large surface area to take up minerals. Okay, so this is the sort of diagram I use in class. Look at the large sandy particles here. The water, the air can move through it, no problem at all. Okay, no problem at all. Look, clay soil particles, small particles, all packed together. The water just sits on the top and can waterlog. In the past exam papers, you got no marks if you said little CEC. If you say no, you had to say no CEC at all. Sean, thank you for that. I will update my notes. Right, you've heard it now, lads. Gospel of Sean. You've heard it now. No, you're so much more fun than Grinds 360, lads. Jesus, that fella. Did he go away? Like, why are you supporting them fellas? Jesus Christ. They're the big pharma. They're big pharmas. Tuition Centre, Grinds 360, big pharma. Support the small boys. Support. Missing mass for this lad. Good man, Sean. Fair play to you. You're spreading the gospel. You're spreading the gospel in your own way, Sean. Good man yourself. Right. Let's keep this going, lads. Soil texture. Okay, texture is all about how the soil feels. Okay, how the soil feels is going to be how much sand, how much silt, how much clay is going to be in it. Okay, a measure of the proportion of sand, silt, and clay in the soil. Our loam soil is equal amounts. Okay, the loam soil is the Sydney Sweeney or is Man City or is Mo Salah of soils. Okay, equal amounts of sand, silt, and clay. Okay, equal proportions of sand, silt, and clay is your loam soil. Okay, soil texture, measure the proportion of your sand, silt, and clay. And then your soil structure, okay, is the arrangement. Think of your house. Okay, this is my house. This is the hall. A real bog standard house. 1, 2, 3 bedrooms. 1 bedroom there. Then there's an old bathroom here, the hot press, and then the cloakroom. Okay, the structure of your house. Okay, same with your soil. The arrangement of the particles. Okay, the structure of your house. Care to explain? No, won't explain that. That's self-explanatory. A soil with a good structure is 50% pore space. Benefits of good soil structure is going to be drainage, retention of water, air movement, root penetration in regards to your tap roots or your fibrous roots. An emergence of your seedlings. Okay, they're the benefits of having good soil structure, the arrangement of your soil particles. Kaylee Foster, what the heck? Soil porosity, okay, is all about the total volume of soil occupied by our pore space. Again, we want 50%. Okay, put a heart beside this, boys and girls. Okay, put a heart beside this. Soil compaction. This is going to come up in the exam. It's too big of a section not to come up in the exam. Okay, what soil compaction is where your soil particles are pressed together and aggregates are destroyed. If the aggregates are destroyed, that means the soil structure is going to be destroyed. Reduces the total pore space in your soil and impacts the drainage and diffusion of gases. Okay, it's going to reduce it. Go back for a second, sound. What do you want to go back for, Cormac? No, we'll have to keep going, Cormac, because we're run out of time. I want to give you a break. Okay. Impacts the drainage and diffusion of gases. Okay, Cormac, ask me a question and I'll answer. And I'll answer it. Impacts soil compaction. Okay, so what are the impacts of soil compaction? What causes soil compaction? Okay, a high stocking rate. Okay, a high stocking rate of your cattle in your strip graze and causing poaching is going to cause soil compaction, and heavy machinery. Okay, so heavy machinery, spreading fertilizer, spreading herbicides in your tillage farms, spreading fertilizer in your dairy and beef farms, all going to cause soil compaction. High stocking rate, heavy machinery, going to cause soil compaction. What is the impact of it? Okay, so impact of it is going to reduce infiltration and drainage naturally. Okay, think of your particles all being compacted together and the water is just going to sit on the top of the soil, okay? Lead to waterlogging, lead to poor drainage. Gaseous exchange is going to be reduced, okay? So there's going to be poor gaseous exchange of less carbon dioxide back into the atmosphere and less O2 into the soil, okay? So that will lead to a build-up. Lower yields, Ron, excellent, okay? So put in lower yields as well. And Ron, just make sure that you're specific about lower yields in regards to grassland or what you're talking about. Just please be specific in the exam tomorrow. Too much CO2 will lead to CO2 toxicity in your soil, and no O2 in your soil means that nothing can carry out respiration. Jesus, no, too busy. You can go for a break if you want. I'm going to keep going here. Plant roots can remove water by small capillary pores, or can't remove water. Plant roots have difficulty penetrating the soil, okay, so poor root development. Repeated tillage operations causes a plow pan, okay, so plowing at the same depth every single year, okay, so look at here, you're plowing at the same, like with your potatoes, 22 centimeters, then you get a layer of a plow pan that develops here, and that is going to be impermeable, okay? It doesn't allow water to pass through, okay? And again, reduces our earthworm population, okay? Not going to be optimal conditions for our earthworms. Our soil, we have 2 more slides to do, lad, okay? So 2 more slides to do. So our soil water, hygroscopic water, this is our soil particle, okay? The water that surrounds our soil particle, okay? So our water that surrounds or thin layer of water that surrounds our soil particle, this cannot be removed from the soil. So cannot be removed from the soil and is unavailable to plants, okay? It's the basic or the foundation level of water in the soil, okay? So a thin film around each of your soil particles can't be removed from the soil. Capillary water, okay? So capillary water moving up, okay? Capillaries moving up, okay? You put the hat on the top of your head or your cap on the top of your head. Capillary water or capillary water is moving up, okay? Moving upwards against the force of gravity, okay? Again, the smaller the pores, the greater the capillary action, okay? Same with your cation exchange. The smaller the pores, the greater your capillary action, or greater your cation exchange, I should say. Smaller the soil particles, the greater the cation exchange. The smaller the soil particles, the greater capillary action. I got it out eventually. Right. Gravitational water, okay. You don't have to be a genius to know what this is water moving down through the soil by gravity, okay? Moves down through the cracks and fissures of your soil, only available on a short-term basis. So hopefully you're happy with those 3 terms. There's nothing really I can do other than explain them. Hopefully you're okay with them and you know them. Hygroscopic water, a thin layer of water around each of your soil particles. Capillary water, movement of water up against gravity. Gravitational water moving down. Right. These 3 here, okay. Field capacity. Field capacity is the amount of water left after the gravitational water has drained away. Amount of water left in the soil after gravitational water has drained away. Okay, so that is your field capacity. Your permanent wilting point is the point at which no more capillary water moves up, can be removed from the soil by the plant roots, okay? Plants will die from drought if the soil reaches the permanent wilting point, okay? So remember, was it last summer, a couple of summers ago, that the grass on the side of the road was going yellow, okay? There was such a drought going on, and nearly happened this year as well. So field capacity is when all gravitational water is drained away. Permanent wilting point is where the plants can absorb no more water from the soil. And then lastly, your available water capacity is the difference, okay? So look at this graph here. Very simply is your field capacity minus your permanent wilting point. I seen an exam question where they gave you the field capacity and the permanent wilting point. We'll just say this is 100 and the permanent wilting point was 20. Calculate the available water capacity. All you do is take it away and you'd get 80 there. Okay, so look at this lovely graph I have done for you. Okay, so this is your field capacity, your blue line. That is how much water is in the soil. after the gravitational water has passed through. This bottom purple line is when there's no water left in the soil, okay? When there's no water left at all, the minimum amount of water in your soil. And the difference here, you see your green arrow, is the available water capacity. I fear of it going for a yellow now. No fear of it going for a yellow now. No, we're all right. Methods of reducing erosion, okay, we have catch crops. Catch crops like our kale, returning to pasture again with our grassland or fibrous roots, installing drainage, again, we're not going to be eroded by the water. Reduce effects of compaction, okay, so try and maybe plow your land, get the subsoiler in, and employ min-till, okay, employ min-till can reduce the effects of soil erosion. Again, our minimum tillage doesn't involve ploughing the land, and we'll call direct drill in our example. Right, very quickly, lads. What happens soil composition during a period of heavy rainfall? Right, what is going to happen? When you min-till the whole time, do you get a plough pad? Yes. No, if you min-till, you're not ploughing. If you're min-tilling, you're just like drilling the seed in. Air, so during heavy rainfall, water increases and the air is going to decrease. Brilliant. Give the percentage of each. Okay, let's go here. Mineral matter. Mineral matter, what percentage? Anyone going to give it to me? 45%, lovely. Organic matter, it's in red. What percentage? 5%, lovely. And these two here, our pore space is going to be 25% each. Remember, we were saying earlier that our pore space needs to be 50%. Two differences between sand and clay soil, right? Let's just comment them out and we'll try and get this done. For nutrition, what benefit including grass in the diet? High productivity, high palatability, high digestibility. Sand particles, clay particles, yes, okay, but what's the difference between them? Particle size, large and small, brilliant. Pore space, sand has no CEC, according to the Gospel of Sean. Thank you, Sean, for that. And then our clay soil is going to be high in cation exchange. Right, texture. Texture, what is texture about? What is texture about? Is the proportion of sand, silt, and clay in our soil. Proportion. Lovely. Sand, silt, and clay. What soil contains equal amounts of our sand, silt, and clay? You won't forget that. Okay, a loam soil. Two benefits of good soil structure. Brilliant. Holly, Sean, Connor, Daniel, Scott, Caroline, all on the loam soil. Two benefits of soil structure. What are they? Reduces erosion. Lovely. Aeration, drainage. Lovely. There are what levels of CO2 and what levels of oxygen in the soil than in the atmosphere. Okay, so there's going to be lower levels of soil or CO2 in the soil and higher levels of oxygen in our soil. How does carbon dioxide and water move in and out of the soil? We discussed it already. It was our diffusion. Right, this is the one I want you to answer. Impacts of soil compaction. Let's go. Number one. Heavy machinery and high stocking rate cause it. Right. Reduced drainage. Reduced drainage, and you're going to expand that point and talk about waterlogging. We're going to talk about lower yields. Excellent. Okay. We're going to have poor aeration. If we have poor aeration, we're going to have low earthworm population. We're going to have high levels of poaching. Brilliant. Okay, you can talk about destroying your soil structure. Right, what type of water is drawn upwards against the force of gravity? Begins with C. A cap. Yes, you put the cap on the top of your head, your capillary. What is the amount of water present after gravitational water has passed through? What is the name of that one? That is, Emma, excellent, is the field capacity. And 3 ways to reduce soil erosion. This is a very classic question. Have a catch crop. Return to pasture. Return to the grassland, the fibrous roots, bind the soil together, improve your soil structure. And Laura, min, till, wonderful. Okay, lads, off you go there. Have a break. Back to beef there for an hour. We'll come back and do beef for an hour. take a break. We'll be back at, what time is this? We'll be back in 20 minutes. Back at 11 o'clock, John O'D. 100%. Good luck to you. Right, I need to stop the recording of this. Right, lads, that was intense. Stop recording.